One of the best ways to prepare for mathematical conversations with our students is by anticipating students' thinking. When we try to imagine what our students might say, we prime ourselves to better hear, understand, and respond to their ideas. Let's look at this image of a group of buttons where we ask, "About how many do you see?" and anticipate some of the many ways that students might think about and answer that question. Let's first acknowledge that there are many students who don't want to answer this question. They don't want to answer about how many they see. They want to answer how many. And they're going to be tempted to count these individually and then report their accurate answer as the most defendable answer possible. But that's not the task here. In fact, estimating can be much more difficult cognitive work than counting. And we want to give students opportunities to estimate with quantities like this one, where you could count the individual objects, especially when students are small, and then move into collections where it wouldn't be possible to count the individual objects, so that they need to estimate. In this group, students might estimate in a variety of ways. First, they might just take a look at the whole image and take a stab at what they think that looks like. This is not a bad strategy, but it's one that needs practice in order to develop it in an accurate way. For instance, some students might look at this whole and say 20. Others might look at it and say 40. Some might say 10. Others might say 50. And still others might simply say a lot. Well, those are very different estimates, and so we need some more evidence in order to defend any one of them. If your students give you a gut response about how many there are, use it as an opportunity to invite others to collect evidence to support or modify that particular estimate. One of the things that makes estimating here particularly challenging is that the buttons aren't the same size. Some of them are rather large and take up a lot of space, whereas others are small and don't take up much space at all. They're also not organized, and there's empty spaces in between some of the buttons, and there's some overlapping too. This means we can't simply use area or structure to estimate, and we're going to have to use some other kinds of strategies. Encourage your students to think about how they might use part of the image to estimate the whole image. There are a variety of ways students might do that. For instance, they might choose a fixed number to count, say 5, and look at how much 5 can look like. So one example of 5 is here, whereas another example is here. And so if we have those two groups of 5 in our mind, taking up this portion of the image, we might think that there's probably another two groups of 5 on the bottom, and therefore there's about 20. Now that's a reasonable estimate. Students might also partition it in terms of area. They might divide the image into quadrants and estimate about how many buttons there are in each quadrant, tackling a smaller estimation project and then putting the numbers back together. So they might do this and say that looks like about 5, 5, 5, and 5, and so I think that there are 20. Notice that they arrive at about the same estimate. Some students might want to partition it differently rather than by area or by focusing on a fixed quantity like 5. Some students might think, well, let's estimate the big buttons first and say maybe that's about 10. And then look at the smaller buttons here and say perhaps that's about 15. And if I add those together, I get 25 as an estimate. That's another very reasonable way of partitioning this image. Some students might want to partition by color, and this is fine, although you can imagine that that can get a little bit tedious when there are as many colors as there are here. To estimate, say, all of the red buttons, and then to estimate all of the green buttons, and then the blue, you'll be tempted to end up actually counting them rather than estimating. With some images, that might be an appropriate strategy. So if there were images of, say, only 3 colors and there were many of each color, that would make a lot of sense to focus on that attribute. So it's not something to simply discourage, but just to point out why in this image it might not be the most effective strategy for decomposing the quantity. When students have experience estimating with images like this one, they can then begin to move on to estimating with larger quantities. But notice how students rely on benchmarks. They'll rely on benchmarks like 5 and 10 to figure out what 5 and 10 look like as a way of understanding what the whole is, as we did in this case. So, in estimating, students are building a deeper understanding of number, of place value, and of the way of decomposing images and number itself. We encourage you to give this kind of activity a try with your students and to not stop at just this group of buttons, but to increase the size, the variety, and the diversity of images that you use with your students.